right now. While you're listening to this, ChatGPT is using about as much electricity as a refrigerator running in your kitchen. Multiply that by a few 100 million conversations happening today, and you've got a problem that's quietly becoming one of the most expensive bottlenecks in tech. We're not talking about some distant future issue. We're talking about data centers pulling so much power that utility companies are literally running out of grid capacity to sell them. So here's the question nobody's asking out loud. What happens when the electricity bill becomes the thing that decides which AI companies survive? Let me unpack the weirdness here, because this story is hiding in plain sight. Last year, data centers consumed around 415 terawatt hours of electricity. That's about 1.5% of all the electricity generated on Earth. Now, 1.5% doesn't sound apocalyptic until you realize it's growing at 12% every single year and accelerating. To put that in perspective, that's roughly the entire annual electricity consumption of a country like the Netherlands. Every year, AI is adding another Netherlands to the global power grid. Here's where it gets weird. When you text your friend, you're using a tiny sliver of energy. When you ask ChatGPT to help you write an email, you're using maybe 100 times more. And when you ask it to generate an image or analyze a video or do something with voice, you've just jumped up another order of magnitude. The fancy term for this is inference load, but what it really means is this. The more clever and multimodal these AI systems become, the hungrier they get. Engineers on Reddit's machine learning forum have been quietly freaking out about this for months. One developer put it bluntly, we're building models that are too expensive to actually run at scale. It's like designing a sports car that costs $10,000 every time you turn it on. And that means we're hitting a wall that nobody saw coming. See, for the last 2 years, the entire AI arms race has been about making models bigger and smarter. More parameters, more training data, more everything. But now, the constraint isn't just how smart you can make the model. It's whether you can afford to keep the lights on when a billion people want to use it at the same time. Here's the thing. This isn't an environmental story dressed up as a tech story. I mean, yes, there's an environmental angle, and it matters, but that's not what's driving the panic in boardrooms right now. This is about cold, hard economics. Power prices are rising in regions where data centers are clustering. In Northern Virginia, which hosts about 70% of the world's internet traffic, the local utility is warning that grid demand could double by the end of the decade. Some AI companies are already being told, we don't have enough electricity to sell you. You'll have to wait, or go somewhere else. So what are they doing? They're getting creative in ways that reveal just how desperate the situation is becoming. Microsoft just signed a deal to restart a reactor at 3 Mile Island. Yes, that 3 Mile Island to power its AI data centers. Google is pouring money into geothermal energy experiments and buying power directly from experimental fusion startups that don't even have working reactors yet. Amazon is building data centers next to natural gas plants and negotiating to run their own private transmission lines. This is not normal corporate behavior. This is what happens when your entire business model depends on a resource you can't reliably buy anymore. Follow the contradiction here, because this is where it gets really interesting. On one hand, AI companies are racing to build the most impressive, most capable models possible. On the other hand, every breakthrough makes the problem worse. The new multimodal models that can see and hear and talk, they're incredible. They're also 2 to 5 times more expensive to run than the previous generation of text-only models. OpenAI's Sam Altman said something fascinating in an offhand comment on Twitter last month. He said the cost of intelligence is going to be the defining challenge of the next 5 years, not the capability. That is stunning admission from someone whose company literally makes the most advanced AI in the world. And what does that mean for normal people who don't care about transformer architectures or terawatt hours? It means 3 things, and they're all happening right now. First, your electricity bill might be about to go up, not because you're using more power, but because the industrial demand from data centers is pushing up wholesale prices in certain regions. If you live near a major data center hub, you're already seeing this. Second, the AI tools you use for free today might not stay free. The venture capital money that's been subsidizing your ChatGPT habit is running out, and companies are doing the math on what it actually costs to let you generate images and have long conversations. Spoiler, it's not sustainable. And third, this is going to change where technology gets built. The future of AI isn't going to be decided by whoever has the best algorithm. It's going to be decided by whoever can get access to cheap, reliable electricity at massive scale. That means places with hydroelectric dams, nuclear plants, or huge solar farms are about to become the new Silicon Valleys. But here's the lurking disaster that nobody wants to talk about yet. If we keep scaling AI at this pace without figuring out the energy equation, we're going to hit a hard ceiling where the world simply cannot generate enough electricity to power the AI economy we're trying to build. And when that happens, something has to give. Either AI stops growing, which seems unlikely given how much money is at stake, or we're going to see a massive, disruptive wave of energy infrastructure projects that make every other tech boom look quaint by comparison. So what does this mean for you tomorrow? Pay attention to which AI companies are talking about efficiency, not just capability. The winners in the next phase of this race are going to be the ones who can deliver intelligence cheaply. And if you're in a field where AI is becoming essential, which is basically every field at this point, start asking questions about the long-term cost structure. Because the era of infinitely cheap, infinitely available AI compute is ending faster than anyone wants to admit. Subscribe to Neural Nuggets for the latest updates in AI.